Information Security, a presentation by Aaron, Andre, James, and Tammy. Today we will discuss the importance of security in DevOps as everyone's job every day by citing a couple of examples of cross-site scripting and SQL injections. eBay has come under criticism for appearing to drag its heels over fixing a cross-site scripting vulnerability which allowed attackers to booby-trap links redirecting users to a phishing page. The hackers had apparently exploited the common vulnerability to inject malicious JavaScript into several listings for cheap iPhones. Once a user clicked on these, they were taken to what appeared to be an eBay login page. However, on further inspection, the page is actually hosted elsewhere and has been designed to harvest user logins for the hackers. Some of the information that was compromised was the eBay's customer name, encrypted password, email address, physical address, phone number, and date of birth. Cross-site scripting is when a hacker injects trusted websites with malicious script. The victim visits this trusted website and triggers the malicious script. The victim's browser executes the malicious script and unknowingly forwards desired information to the hacker. How can we stop cross-site scripting breaches? Some possible cross-site scripting solutions that we should integrate into our security deployment pipeline is static analysis testing. This is testing that we perform in a non-runtime environment, ideally in the deployment pipeline. Typically, a static analysis tool will inspect program code for all possible runtime behavior and seek out coding flaws, backdoors, and potential malicious code. This is also known as testing from the inside out. We should also probably implement dynamic analysis testing, which is a test that tests the functionality, behavior, response time, and overall performance of the system, looking for intrusions that would cause the system to act differently. This is called outside-in testing. Another option that eBay could offer is a template for the users to use, as far as all they have to do is input the text of the item and a picture of the item and then submit it to be tested before it's put live on the website. Implementing these solutions possibly could assist eBay in overcoming any cross-site scripting data breaches in the future.
One of the most alarming things about this incident is that it took an outside source to find the problem and took over 3 months to fix it once it was found. Here are some ways eBay could improve finding and solving problems in the future. They should conduct postmortems after each security incident. These can be used to educate engineers on how to prevent similar problems in the future. They should also define design patterns to help developers write code that prevents abuse. Cross-site scripting is such a large problem that OWASP lists it in their top 10 security issues and publishes guidance on how to prevent cross-site scripting. They should integrate security telemetry into their application to detect problems as they happen, and the telemetry results should be integrated into the same tools that dev and ops are using. This will give visibility into how the apps is performing in a hostile environment. Finally, they should radiate how the attacks are happening. Increasing visibility of attacks will serve to encourage everyone to think about security in the future.
Back in 2008, Heartland Payment Systems, one of the largest payments processor in the US, was the target of a massive data breach. According to one estimate, about 100 million cards and more than 600 financial services companies were compromised, with a resulting cost of hundreds of millions of dollars. The threat actors were able to subtract the financial data, so card numbers and associated information, by using first an attack called SQL injection to penetrate the networks, and then other programs called sniffers to collect and steal network data. Sometimes, in the rush to move applications to the web layer, companies don't check properly for SQL injection vulnerabilities and leave themselves vulnerable to attacks. When a web application is properly coded, then anything entered in an input field is thoroughly scrubbed and cleaned until it can do no harm. If that is not the case, malicious code can be passed to the backend database server and, for example, retrieve information that companies never meant to expose, including user passwords in clear text, or perform database operations never meant to be executed, such as record deletions or tables dropping. One solution to mitigate this type of attack can be a web application firewall, which inspects applications based on the HTTP protocol and can be an hardware appliance or a software plugin. However, instead of relying just on a security tool, the best defense is a robust design of the application itself. The developers must design ways to sanitize all input and remove malicious code elements from it. It is also a good practice to turn off the visibility of database errors on production sites, just because they can be used with SQL injection to gain information about the database itself.
Now this is where we get to really prevent SQL injection by using parameterized inputs, and I will explain what this means. Here we have a register client function that is used in site registration of handling like new user creation. That's just fine. Here we see that the function is taking a bunch of arguments, presumably from the front end of the web application, such as a form with the post method, for instance, and throwing it directly into a SQL statement. This is bad. Very bad. Vastly, hugely, mind-bogglingly bad. This is basically how you make your website vulnerable to SQL injection. Oftentimes this is a function of testing and neglecting to think about it, essentially. It's also just faster to do it this way. It's also very bad. Here we have an example of good parameterized input use. Here we have the exact same function as before, accepting inputs from presumably the front end of the web application, perhaps that it had been validated or sanitized. We don't know, it just takes the parameters and does what it does. First it initiates a database connection, and then it uses what's called a prepared statement. Now this is basically an empty shell of a SQL statement that has no actual data put into it yet. And then we prepare the statement, and then we bind our values using the PDO object library. Tell it what kind of variable it should be expecting there into the SQL statement, execute the statement, see what we return, etc., etc., same as before. The difference here is that we are escaping the input of the user. So instead of allowing the user's input to be directly put into a SQL statement, we are chopping it up and putting it into a prepared statement the way that we want it to go. So for instance, if the user put single quote admin or admin single quote 1 equals 1, or some of the classic SQL injection testing methods, they would be met with nothing, because their entire username would be, admin single quote, etc., etc. It simply throws it into the database as it is, instead of directly taking the user input and modifying the query based on the user input, because the user has been, their ability to interface directly with the SQL statement has been taken from them, as well it should. Hello, this is just a quick demonstration of how you can use SQL injection to bypass login authentication. This is a simple web application with minimal backend, courtesy of HackerOne. Fantastic site if you want to learn hacking, highly recommend. So what we have here is a very simple web page, no styling, not pretty at all. And we see that if we want to create a new page, we have to log in. Well, let's try and log in as admin for reasons. Just put in a password that makes no sense. Unknown user. We've got nothing. Alright, so let's see if it's vulnerable to SQL injection. And one of the things that we can do to do that is just throw a single quote into the username field. Password, let's just throw the letter R for pirating. Log in. Pardon my last pass plugin, but here we have an error message from the database. So this is why you need to disable error messaging in your web application, because this can show up. Here in this line we see that there's an if statement, and we have the entire structure of the SQL statement used to insert into the database, or to validate users against the database. We see that there's a table called admins. We see that it's looking for a username request form, and it's doing some input sanitization there. And yeah, it's all over. It's all over now. Like that, this is it. So we can just go back. Now, a hacker will have to do this by trial and error, which I have spectacularly done for you beforehand, so that we don't have to worry about exactly how to exploit this particular vulnerability. Just know that it totally is possible, and I'm going to do it right now. So for username, we're going to put rar, and then that single quote to then break the SQL statement. So what I put in there was this string, so that you can see it better. Here we're breaking out of the insert statement from before, and instead we're unioning this as a password from admins where 1 is equal to 1. Well, when is 1 equal to 1? Always. So in the password field, we're looking for ah. So let's just put ah into the password. Log in. What do you know? We're logged in with admin credentials. Now we can see the private page. We can look at the changelog. We can edit this page. We can do all sorts of things. This has been a quick demonstration as to why and how just one of the ways that the SQL injection can be used to damage a web application.
In this presentation, we have talked about 2 data security incidents involving cross-site scripting and SQL injection attacks. These attacks together compromise sensitive data for approximately 250 million people. We have also talked about steps to respond to and prevent similar events in the future. These incidents happen to large companies dealing with millions of user accounts, but it is likely that the smaller websites we create will face similar attacks. Whatever our role, we each need to be aware of vulnerabilities and do what we can to help mitigate them. Anytime we deal with sensitive data, it is crucial to keep information security in mind, because protecting data is everyone's responsibility.